Good evening, everybody. My name is Austin Williamson. I'm Vice Chair of Sibsey Home Counties North East and also Regional Representative on behalf of the SLL. The CPD this evening will be based around the design and specification of smart lighting control systems and wireless-based control systems for the application of commercial buildings and data centres. A CPD certificate will be issued at the end of the CPD or via email separately, providing all attendees obviously register through the actual various through the link that you should have hopefully received. The CPD will last approximately 45 minutes. And we'll be taking some questions and answers at the end of the CPD, ideally via the chat box. Anyway, without further ado, I will hand you over to Martin at Zencontrol. Thank you.
Thanks, Austin. Hi, everybody, and thanks for joining the CPD this afternoon. So, hi, I'm Martin Hine, your presenter for today. I work for Zencontrols, lighting control company in the UK. My background is basically 25 years of involvement in industrial automation, building automation, and in the most recent years, lighting control systems. And today we are going to go over the DALI standards, the latest DALI standards for lighting, based around the DALI 2 enhanced standard and DALI Plus, which is around the wireless lighting. So DALI, which is the digital addressable lighting interface, it's a standard that's been established since the mid-90s. As for lighting controls by the main lighting equipment manufacturers, in essence to supersede the original 1 to 10 or 0 to 10 volt analog dimming systems that was originally doing lighting controls. And really, DALI as a digital addressable lighting control system is pretty much standard in most applications today. Within the DALI Alliance brands, there are a few areas that we look at, and we're going to look at today. We've got the DALI 2, which is the enhancement to the original DALI standard. So originally, when DALI came out in the mid-90s, it was specifically aimed at just the luminaire manufacturers themselves, and not the emphasis on so much the actual controls. DALI 2 now looks at this as a more interoperable solution. D4I is the standard for interluminaire connection of DALI, so transmitting the DALI information and energy information, basically IoT information, direct from the likes of light fittings, street lights, and luminaires, where the actual driver itself provides the DALI power from within the driver. There's no need for an external power supply, and this information can just be sent wirelessly from the fittings. And DALI Plus is the newest standard, certified standard for wireless applications. So DALI is also an IEC standard, so it's an international standard, recognised standard within the industry. So this encompasses a focus on a universal language for digital communication between components, including the fixtures, control gears, sensors, and user interfaces. This also looks at the interoperability between manufacturers, the communication and the flexibility to the users, and also encompasses simplified installations by encompassing the standardized communication protocol, saving time and resources. There's also a lot of enhanced functionality within the latest IEC standards within the DALI 2 that we're going to go over. And there's quite a few additional parts to the standard which have been introduced since DALI 2 and the DALI Plus. So DALI 2. So the original DALI standard, as I say, only encompassed the driver manufacturers in the original DALI standard. So this meant that various lighting control companies were producing lighting controls to speak to any of the standard luminaire manufacturers. But what this didn't offer was the interoperability between products on the market. The new DALI 2 standard now provides full compliance and operations of third-party manufactured products, such as the occupancy sensors, such as PIRs, which provide presence, absence, your lux levels, and also input devices, such as your switches, scene plates. So there's a full ratification now between manufacturers under the DALI standard of devices that can be used, interoperability between systems. So in essence, you can have multiple products from multiple manufacturers use within the same DALI network. And this wasn't available before with standard DALI systems. So you're very much tied to the manufacturer of the lighting control in terms of controlling the system, but obviously previously you can ensure connectivity to any luminaire driver manufacturer, whether that be Tridonic, Philips, or Osram, but obviously you wouldn't be able to mix and match manufacturers' devices until the new DALI 2 standard has come out. So obviously this means simpler wiring. So within the DALI network, you have one control line for the lighting, emergency and scene switches and sensors. It's the same network connectivity as DALI has been recognised previously, but it just means that you can have all of the devices without the need of any third-party protocols or bus systems to connect to proprietary manufacturers' sensors or switches. All of these products and components can be added to the standard DALI network. So there are standard general requirements within the DALI. We have part 101, which covers the system itself. You've got 102, which is a control gear, 103, control devices, etc. So these are sort of standard products that have now been enhanced with the DALI 2. You've also then got the standard parts for the control gears. So the control gear products such as emergency devices for the lighting control system to perform function and duration tests in order to do the emergency testing and pick up the information from the drivers in terms of the status of the battery, failures for the maintenance. You've also got the enhancement for picking up LED modules. So you can look at the color changing from RGB to circadian rhythm lighting, using DT device type 6 and also color changing with device type 8. And then there's also the additional features within the drivers, such as integrated bus power supply, luminaire data, and energy data. So these areas here are specifically useful when you look at Part L 6.6 requirement. So where there's a metering or sub-metering, there's also a clause in there that says that you can actually monitor the data from the luminaires via the lighting control solution. This is possible now with the DALI 2 drivers that are providing this real-time information direct from the drivers. Before DALI 2, you would have to make a calculation based on the luminaire information of the driver in terms of wattage, current, voltage, and the lighting control system would then be able to work out based on the light level some information and then provide an indicative analytics on the watts per metered square or cost for a group of lights within the floor space. Now with DALI 2 providing the drivers providing this information directly, this means that the data is more real time direct to the lighting control system. This can also be advantageous towards some of the other standards such as the NABERS. NABERS is obviously, or neighbours, requires this data to be provided in order to achieve the highest level of the neighbours rating. And then we've got control devices. So as part of the DALI 2 now, where it does include the additions of manufacturers' products, such as the push buttons, inputs, sensors, etc. So really, when designing a lighting control solution or looking at future-proofing the building, it's quite important that, you know, looking at DALI 2 as a solution moving forward is a good way to ensure that the wiring and the infrastructure of the lighting control within the ceiling is future-proofed. So if anything changes down the line, you can change manufacturers' products and there's less disruption to the ceiling and the wiring moving forward. There's also additional features that are still in progress, such as Bluetooth and other wireless systems such as Zigbee. But there is a wireless solution that we talk about through DALI, which is the wireless thread, which is certified and available at the moment. So when we look at the DALI circuitry, so really this is no different than the original DALI. So DALI as a bus wire is a 2-core system. It originally is powered from a 250 milliamp power supply, and the controller in the riser will provide the DALI connection and up to 300 meters of bus network, utilizing 250 milliamps to power the devices on the network. So with DALI, the original DALI, the controllers would only recognize really as part of the standard the luminaires, and anything else that was attached to that DALI network would in essence be proprietary to the lighting control manufacturer. Now we have DALI 2. The controllers are open to any manufacturer that is connected to that DALI network. So that would be the sensor, your emergency fitting, your switch, and your light fitting. From the application controller, the DALI 2, that is connected directly onto the backbone of the building via an Ethernet connection. This Ethernet connection connects to, say, the converged network of the building, and then allows all the data from the application controller to be presented within the lighting controls head end, whether that be on site or via the cloud in terms of a GUI. And also the data from the application controller can be exported to other systems such as the BMS or smart enablement systems over the cloud. And these may require the connection of a protocol, different protocols from the application controller over the network, such as maybe BACnet protocol or MQTT. So the key components of a DALI 2 system, as certified under the IEC standard, we have an application controller, and the application controller is there to the overall system control serves as the central hub for the DALI 2 network attached to it. And it connects to all of the ballasts and the drivers and the sensors to coordinate their functions according to the scenarios, the light scenarios, and the scope of works that is required for the lighting control. So the communication interface in the application controller between the DALI 2 network system and the external systems, as I said, connects via the Ethernet ports attached to the application controller, and these will then go off to the BMS and other third-party applications if required. From the application controller, you can then manage groups and scenes of lights. So you can define areas over the DALI network. You can create the scenes for different moods, and you can also control not just internal devices, but also external devices as well. So if it's not a direct DALI driver, you can put in place DALI relays or dimmer modules in order to control non-DALI fittings. Obviously, with the sensor integration, DALI 2 also supports various sensors, including the occupancy, the daylight for monitoring the light levels to comply with the constant light control for lighting close to windows or south-facing windows where there's increased light levels. The lighting controls can use the sensors to reduce the light levels of the fittings near the windows, and in addition to that, you can use the sensors for absence detection and there's increased information also from an environmental point of view in terms of some of the smart sensors that are available, which can also, within the same sensor, harvest temperature, humidity, noise, and CO2 and various other elements over the DALI network. So the overall system control of the application has various elements to it. We have the single master solution and multi-master solution. So there is the functionality to have multi-master controllers on the network, doing various tasks with redundancy, and you could have the one controller monitoring one area of just emergency information, and then you can have another controller on the same network controlling the lighting. Obviously, so as mentioned earlier, the power supply. So we have standard IEC power supply for the DALI network. The DALI 2 power supply is obviously a critical component for the network, and it supplies the 250 milliamps for the devices. This voltage output is usually standardized at 16 volts. While the current output can vary depending on the number of devices connected to the network, but common rating is 250 milliamps over 300 meters of a network. So most applications, won't exceed the 300 meters from one power supply. The way that most projects are calculated is the drivers themselves will take up to 2 milliamps roughly. Sensors and switches can take anything between 4 and 6 milliamps on the consumption. So when designing and looking at a network on the DALI, on a DALI channel, these are the things that you take into consideration when deciding how many devices each DALI controller or DALI channel is able to control and support. There is also remote DALI power supplies that can be introduced within the luminaires to increase the power from the devices. Also, these can be used in conjunctions to wireless applications as well. So if there's no area controller or application controller with a DALI power supply in the riser, then and there's a wireless system, you need to create a power supply within the luminaire itself, and you can put these units in alongside the driver to create the DALI bus required to power the internal sensor of the luminaire, and then create a network back to a wireless controller in the riser. So the DALI 2 sensors that were mentioned before are part of the 306, as part of 306 are the environmental sensor. So these are a very new sort of area, especially where the standards now are looking for smart enablement within buildings. You've also got the WELL standard. So in addition to your standard lighting control functionality like your occupancy and presence and daylight, the standards are now asking for air quality or environmental sensing as well. And as part of the 306, we can obviously offer additional features such as CO2, humidity, temperature, and noise. And these areas do help towards achieving the certain points within these standards, such as WELL and Neighbours and Smart School. And some of the applications that are looking at these, apart from say your standard office environment, looking at the wellness of the standard office. You've also got your hospital applications where things like humidity and temperature are quite crucial to monitor. So having this as part of the DALI system is quite unique, but it means that you've also got a lot more sensors in the ceiling, providing a much granular data for the analytics. So rather than having third-party systems on a different separate network or proprietary network at just small locations, if you've already got the lighting control sensors in place, and there tends to be more of them for the coverage of the area, then you get a much granular data information. Switches, DALI 2 switches and user interfaces. These are obviously designed to provide control of the lighting control system. These come in various different flavors from various different manufacturers, but generally you'd have a scene plate or a switch to allow on, off or dimming. The scene plates can also offer the chance to control individual groups and scenes. So if you have a meeting room and you want to present a scene, you could program the system via the switches to create that scene. You can also have intelligent touch panels that allows you to go between the lighting, the HVAC, the blind controls and AV. So we over the communication, it's backwards compatible, bidirectional information through the DALI to the third-party systems through the application controller to the BMS via BACnet or MQTT to third-party products. You can create this bidirectional control over the DALI network to various types of switch interfaces. DALI relays. So there's a range of DALI relays that can be used for various functions, such as switching of loads for non-DALI light fittings, for example, solenoid valves for BREEAM applications, fan controllers, blind applications. So most applications, as I say, with BREEAM, the lighting control tends to take control of the water solenoids. As someone enters a room, the sensors identify presence, and then they can switch the relevant solenoids on and off. These are particularly used a lot in the commercial shell and core landlords' toilets, cores, and also in hospital environments. Switch even not just the toilets, but solenoids, but the individual sinks within rooms as well. Now, DALI Plus is the latest wireless DALI standard, and DALI Plus refers to a logical arrangement of devices within a DALI digital lighting interface plus. It encompasses how DALI devices are connected and organized to form a mesh network within the ceiling. The mesh topology involves various products, devices, forming a mesh network where each device in the ceiling can communicate directly with multiple neighboring devices. So you've got sensors, you've got your switches, you've got your drivers, emergency fittings. These then communicate back to an application controller, a wireless application controller, which also sits on the IP backbone of the building. So the key components of the wireless application is the wireless application controller. This is a DALI Plus certified, and it's part 104 of the IEC 62386 standard, and it utilizes thread. And Thread is an IPv6 low power mesh network designed for IoT network products or applications. It's also backed by brands such as Amazon, Google, Siemens, Somfy, and you probably recognise, the likes of Google Nest home automation. These are the sort of products that use Thread as a system, as a protocol. And IPv6 is based in most of our home networks now. So this is one of the first certified wireless DALI Plus protocol, and there are other different solutions in the market, which we've heard of, such as Bluetooth, etc., but they're not actually certified as a standard IEC for DALI yet. So there will be developments being done for the future, but the Thread at the moment is the first that is actually certified for doing wireless. And it's quite exciting because it still provides the full functionality of DALI 2 in terms of the interoperability between cross manufacturers. So as other manufacturers produce their own Thread devices, we can adopt them into the same network. And you can still have, from each wireless application controller, you can still talk to 63 devices, luminaires, and 63 control devices. And this is connected onto your IP backbone of the building. The sensors, same, they're part of the 104. And if we look at the IEC references here, these are the standard parts here that these sensors comply to. So you get the same functionality, presence, absence, lux control, as you will with the DALI system, but these are powered just from the mains. There's no physical DALI pair, and the information is transmitted over the Thread network. Again, for the DALI Plus input devices, you've got a bridge which provides the power. So if you have a mains switch and you want to make that wireless, you introduce the wireless power supply bridge, and that can make that switch a wireless switch. Touch panels and scene plates come with the wireless thread built into them, and again you have the sensors there as well. In addition to that, you might find that just a wireless system on its own, it doesn't meet the requirement of the building. And wireless can be really suited towards maybe a smaller percentage of projects at the moment. But generally, the shell and core, you might find, is more suited to a wired DALI system. So utilising the backbone of the building, you can introduce an application controller to connect a wired DALI network to the devices up the core, in the corridors, in the toilet, in the community areas, etc. And then within the office areas, you can introduce the wireless application controller for those areas. In particular, we see wireless quite attractive in grade listed buildings where wiring and introducing new bus cables is difficult to do. So and also applications like museums where devices might need to be moved, and of course when you move devices you've got less availability to be able to reintroduce new cabling to the new areas wherever you're moving your devices. So wireless does have its application, but in the general scheme of things, within most of the commercial applications for offices and others, wired is still a preferred method of doing DALI control. So commissioning of the DALI system. Commissioning is done via the GUI or digital interface, and the system can be designed to easily from a application at shell and core to Cat A, and then into the Cat B installation for the tenant. It can be all configured digitally using the software. So each area can be regrouped to suit the demise of the customers, with very little need to do rewiring of circuits. So it's easier and more flexible for the user. Again, we've got a large array of devices that can be put onto the network. There's really no limitation, apart from each DALI line has its 64 addresses for the lights and the control devices. The number of applications on the network, there you can have as many as you like. So again, really an overview here from the network side of it. Really, DALI 2 is deployed the same as a network as a DALI system, but obviously you have the enhanced number of devices on DALI 2 now, as opposed to your 64 addresses for your lights. You now have the interoperability between manufacturers for your switches and your sensors on that network as well. And for ease, the system is connected directly into the IP network. Most buildings now are going with smart score, wired score, and converged networks becoming a standard within the buildings. So this is great to just connect straight onto that network. So it offers a standardized deployment and design and future building blocks for the future enhancements of the building. It makes it future proof. So most of the application controllers will be smart ready. So at day one, if there's no need to connect to the BMS or the smart enablement via the cloud, third-party cloud systems, then they can be implemented in the future. But at least they're connected onto the system's connected onto a smart ready IP network. The fault management is increased through the DALI 2 network, so we're able to pick up all of the devices on the network and provide all of the diagnostics. And from a security point of view, all the systems are designed with the latest VPNs and firewalls in mind for the IP networks. So they are pen tested in order to be checked for cybersecurity. They have to be in order to be able to transmit this kind of information to these third-party systems. And also using MQTT, you have special packets of information. But these are backed up through the CNS network for increased resilience. But most of the IP application controllers would go through stringent cybersecurity to make sure they meet all of the requirements. So MQTT, just looking a little bit more into the MQTT side of it, the integration from the actual application controller itself. It gathers all the information from the DALI 2 network of devices, and in order to export this information to a third-party system in the cloud, there's a naming convention that's created by the client, and then the information is sent through the internet to the client's broker. The client's broker will subscribe and for the information, and the third-party analytics, or whoever is employed by the client in order to provide further analytics, will subscribe from the broker the information that they require. And this doesn't just come from the lighting, it comes from the BMS, it comes from the security. MQTT is a standard protocol that's used for exporting data from buildings into the cloud. And generally the client owns the broker. So the client owns the broker, which is the server, which is collecting all this information from the building in their language, their naming convention. And then whoever is employed to provide an app, an analytics package, can then basically subscribe to that information. There's also other lighting control elements on the integration, such as DMX. And DMX is another color changing element. But in between the application controller, you can do various different integrations to third-party products. So whether it's DALI, DALI 2, or DMX, these are the sort of different lighting control elements that are required within most lighting control applications. And BACnet is the interface between the lighting and the BMS. So the BMS will tend to, require such information from the presence detectors to say there's presence in a room to actually maybe activate a fan coil unit or a VAV system. But they can also take other information from the lighting, such as the emergency information can be transmitted through to the BMS. And sometimes the BMS does provide an energy management system, and that energy management system does require the additional information from the DALI 2 drivers as well. So the general integration from a lighting is over IP within the building, and it's generally a BACnet interface. If it's outside to the cloud, it'll be normally through what they call MQTT. So there's various different software applications. Generally, the lighting control will provide the overview of the building. It will provide the layout of every floor, every room, and it will cover all of the diagnostics and key information on faults from the system. And with DALI 2, it will list all of the devices that are within that building, and allow the FM to be able to maintain, easily replace devices that fail, and also perform the required emergency testing that is required, and furthermore to look at additional analytics from within the building, whether that will be the power usage from the DALI 2 devices that we spoke about earlier, or general occupancy from smarter sensors within the building. So really health monitoring, status of lamps, reporting individual control gear, statuses on-off statuses, dim levels, lamp failures, and ballast information are all standard requirements from a lighting control system. Obviously, error reporting, predictive maintenance. These are things that the FM requires, and really with DALI 2, you get far more enhanced information from the network of devices, and with the latest head-end systems connected to the network of the building, these can be viewed not just from locally on site. Again, they can be viewed from a tablet or a PC outside of the building or on any floor just by going through the browser into the internet. In addition to monitoring, there is the facility within the lighting control to make changes to the system, changing time regimes, fade rates, light levels. All of these things can be adjusted from the head end. So we look at improved device interoperability with the latest DALI. You're getting increased device information from the system. We're enhancing the diagnostic and monitoring because we can see all the devices on the network. We've got increased sensor information, so with environmental sensors and the air quality sensors and general multi-sensors, we can get all of this information now. We've now got additional features for the energy management, so utilising the latest DALI 2 drivers, parts 251, 252, 253. We can get real-time information from the drivers. We've also got the enhanced control features. We can now bring in a multitude of input devices, and we also have the functionality of the smart IoT application controller features and network and system data. So we can connect onto the backbone of the building through the standard application controller and provide enhanced system information to the network. So DALI 2, as an enhancement of DALI, provides the interoperability and backwards compatibility and future proofing to the client. It reduces their OPEX costs through more flexibility, the chance to easily add devices to the network, reduction of wiring within the ceiling. You've also now got the DALI wireless, so DALI Plus. So the future of application within the DALI wireless applications will grow. There'll be more and more applications as more and more manufacturers come on board, providing a range of products. This always brings costs down, so the flexibility of multiple manufacturers. And obviously Thread, as we spoke about, is a growing protocol, but along with that, there will be others as well to increase the portfolio of devices that can be introduced to the DALI standard. And of course, you don't just have to go for one type. You can have a hybrid approach of network DALI and wireless devices to coexist within the same network of the building to provide the best solution for that application. And that's the presentation. Thank you very much. If you want further information on lighting controls from Zen, then please feel free to email me. We also feel free to have a look at the Zencontrol website or follow us on LinkedIn, and open the floor to any questions.
Yes, thank you, Martin, for that, and very interesting, informative presentation on lighting and lighting control systems. Yes, as Martin said, we can accept any comments or questions via the chat, and I think between me and Martin, we'll try and respond to them. Thank you.
Just close that presentation down. There we go.
Turn my camera off again.
That's all right, no problem. Okay, so I've just got here. Brilliant. So, if anyone's looking at currently looking at specifying lighting controls, what sort of things have you, what sort of requirements do you have? What sort of barriers or hurdles do you have? Do you think that this, certainly DALI 2 is something that will benefit? Have you heard of DALI 2 before? Maybe you haven't. Integration, smart building. Hello.
Yep. Yep. Sorry, Martin. I think we've got our first couple of questions coming in.
Yeah.
I think from Cam or Mac. Has this been applied on street lighting anywhere?
Yeah, so quite a few of the street lighting manufacturers actually use DALI already. So the D4I protocol. So obviously, to have an application controller on a street lighting solution where you're supplying the DALI power supply external to the lamp is not an easy installation. So this is where D4I comes into it. So the driver within the lamp itself, or the street light, has the sensor on the top, and the D4I driver will supply the DALI power to that sensor to read the information, lux, presence, etc. And then also to control the dimming levels of the light. So I think you'll find most of the street lighting companies do actually use DALI already. We do have applications where you've got car park lighting, where we would introduce a network DALI system sometimes. That's specifically if the drivers for the light fittings are actually mounted within the stem of the actual external lamp.
Okay, thanks for that. I think question here from Paul: are the DALI 2 kinetic type seam plates? Question
Say
mark.
again, Austin?
Are there DALI 2 kinetic type seam plates?
Kinetic type seam plates. So are you sort of referring to wireless type seam plates?
Oh, possibly, yes, if I'm reading the question correctly.
Yeah, wireless. Yeah. Okay. Yes, there are. So there are a range of wireless devices now that we can read over thread to create them, and the kinetic side is very similar to the N-Ocean, if you like, but they do need power. So there is a way of creating a wireless switch. It'd be battery powered, not mains powered, and you can then put an interface with it to turn it into a DALI device. So yes, there is devices available.
Okay. The next one, Elwin, when would D4I typically be required over a DALI 2 system?
Yeah, interesting question. I think so the street light applications are definitely an application where D4I has been used. If you don't require, if you want a standalone system, then D4I is quite useful. If you're not required to have a head-end PC or a GUI and a network, then D4I could be useful for that. But generally, I think applications in Europe probably use D4I more than they do in the UK. Most of the applications in the UK require all the monitoring to go back to a head end. But as long as you've got some kind of a wireless gateway, then there's no reason we shouldn't be able to gather that information from the D4I as well. But you would need to ensure that the D4I is also connected to a wireless bridge.
Okay. Next one again from Cam Mac. Is D4I technology constrained by distance between light fittings?
No, because it's a local independent control. So you have to look into the D4I standard a little bit more on that, but it's not a mesh. So you would create a mesh, and then once you create a mesh for the D4I network, then you'll be constrained to the DALI wireless mesh network, which will be whatever that technology. So with Thread, I think it's something like 10 to 15 meters between devices. So that would be a limitation once you make it wireless. But D4I is really the driver providing the power supply for the devices it's connected to locally. And then you put your mesh on there. So yeah, 10 to 15 meters once you've created a wireless mesh.
Okay. I think that's clarification from Paul. It's wireless.
Yeah.
Okay. Back to the earlier.
So that was the switch. The switch. Yeah. Yep. So yes, we can provide kinetic wireless switches. Okay. Fantastic.
Great questions. Oh, yeah. Thanks very much. Does the DALI Plus follow any specific cybersecurity standard or guidance? That's an interesting one.
There will be, yes.
Yeah.
And to go deeper into the cybersecurity side, there is a whole section listed on the DIIA website. So the DALI Illumination Interface Alliance, DIIA, sorry, get the letters out right. They list more information on the individual protocols and the cybersecurity. So that's the best place to have a look for that side. But generally, anything that's going to go wireless or on a network through an application controller or onto a network will meet the highest of the cybersecurity.
Okay, thank you. One here from Hazel. Is the DALI Plus wireless system compatible with emergency monitoring and testing yet?
I believe so, yes.
Yes, I would have thought so. Emergency monitoring, testing. Okay.
So you're just basically adding. So you're adding your emergency driver in situ to the D4I.
Yeah.
So basically, yes, you can still gather the information. It's just that the power supply is within the D4I driver. So we've done applications before where some of the fittings are coming with the D4I drivers in, supplying the power. And when you've already got an application controller in the riser with the power supply supplied for the network to the normal DALI fittings, and then you realise you've got a clash of two DALI power supplies on the network.
Yeah.
But yeah, it will support that. Yeah.
Okay, next one from Simone. I work with manufacturers, many of whom seem reluctant to adopt controls for security reasons. How are these concerns taken into account by the DALI Alliance and DALI standards? There's a great potential to improve efficiency through controls. It is difficult to make clients embrace it for those security concerns. I think that's similar to the other one we just had. Basically,
yeah. So
I think. Sorry, go on. Sorry, Martin.
No, go on. Oh, again, it is really dependent on the interface that the DALI is going through. So obviously, you know, once the application controllers are designed to sit on an IP network, so they have to be pen tested and resilient to meet the security requirements. Most CNS converged network systems have their own cyber security VPNs built into them. So generally, in most of the lighting control applications that we do, which is smart enablement, the application controllers meet all of those requirements. You know, the lighting control application controllers on IP networks are being installed within the highest tech companies such as Google and Facebook and people like that, and the banks. So the security is always taken care of from there on the VPN networks. So there's VPNs over VPNs over VPNs to ensure that, you know, people can't hack into those different subsystems within the network. But I suppose, like anything, if someone's really you know, adamant they want to hack into something, they're going to find a way somewhere. But you know, the converged IP networks do make it very difficult for them to do it.
Yeah, I think that's more of a wider question as well in security and cyber security. That's going to cover many systems and many aspects of technology systems, not just lighting. But it's still a very good question.
Yes,
One more. I think that's from Cam. Cam may contact you later separately.
Yeah.
Yeah,
Fantastic.
that's absolutely fine. Matthew, thank you. Elsa, how does D4I ensure compatibility with other lighting control standards and brands? As interoperability is an important factor to consider when selecting lighting control systems for a building, thinking about KNX, Longworks, Modbus, which are often used in building automation systems. Yep, that's an interesting question as well. It's compatibility, isn't it?
Again, but it's yeah. When we say compatibility, it's D4I is again it's providing the DALI power supply within the driver, and it's still providing all the information that DALI is providing from the luminaire. So it's the control and the information. So whatever the driver provides the power to the sensor then reads the lux presence or whatever, and the control is within the driver to the light fitting. So all the information from there can be exported wirelessly or on the network, and the compatibility between third-party products is part of the DALI. So if the sensors are DALI standard, a DALI device, it can be used on within a D4I driver. So if the luminaire or the street lighting manufacturer chooses a different PIR from a different manufacturer, then they can do that. KNX is you know an open protocol as well, but it's not as recognised within the commercial applications. It's more of a high-end resi application in the UK as opposed to Europe, which is more frequent in Europe because there's a lot more people trained on KNX, but the costs are too high in the UK for KNX to be viable for most applications. But it still is open protocol to certain manufacturers, like you say.
Thank you, Martin. Again, thank you. Another question from Salam. Is it better to use other systems like BACnet, KNX, or Ethernet in big projects to connect the DALI controller?
So most applications now, the future of buildings, the way things are going, you know, most buildings have an IP converged network in. So it's a standard now to connect all devices within the building onto the converged network, whether that be a lighting control device, fire alarm, BMS. So they're already connected onto the IP network, and the protocols, the standard protocols used within the building is for communication between the BMS and the lighting is BACnet. Modbus is a register-based system. BACnet is defined a clearer set of information. So each device on the BACnet network, when you scan the devices, it clearly has a label for every single input or output. So if it scanned the network of application controllers, it'll see a range of lamps 1 to 10, for example, switched inputs in locations, etc. And the associated information on emergency fittings, etc. If it was Modbus, it's just registers that, unless you look at a table, you don't know what that register means. So the preferred method now within buildings is BACnet over IP for that integration.
Okay, thank you. Next one from our colleague Stuart, who sits on the DIA framework for cybersecurity is a big topic. An updated technical paper stroke standard is due for release. So that's for everyone's information from Stuart.
Okay. Brilliant.
And thank you from Elsa. And I think that's the end on this.
Excellent.
Yeah, it looks like the end of the questions. Well, thanks for everybody's contribution to the questions as well. Much appreciated.
Yes, thank you.
And thanks also to Martin and the Zencontrol team for the presentation. That's excellent. And
That's
I hope
right.
everyone enjoyed it.
And again, yeah, brilliant. Thank you. And again, I mean, I'll share the presentation with you, Austin, and if anyone wants to get in touch, then please do.
Yeah, I'll speak to Sibsy, and that would normally, the presentations will go on the Sibsy Knowledge Portal as well.
Okay.
For future reference.
Yeah. Okay, that's brilliant. Okay, super.
Okay, thanks so much, everybody. Thanks so much, Martin. Have a good evening. Thank you.
Thank you. Cheers.
Thank you. Bye. Bye.
Bye-bye. Bye-bye. Thank you all.